Hello. Um, I don't know. I guess I'm gonna talk about flat Earth. uh, and I don't want to purposely clash with your opinions or beliefs and blah blah blah. Believe whatever you want. Just, you know, leave it out of the classroom because science doesn't care about what you believe. Not even the scientists. It doesn't care. It doesn't give a damn. The universe doesn't give a damn. It is what it is, and that's not going to change just because you want it to or you believe it should be this way or blah blah blah. Anyway, I don't know. I just find it funny to go through the logic of it, and so I'm gonna do that. Let's go through some of the basics, okay? Why the hell do we have a horizon? There's a reason, and it's pretty simple. It's not just because, oh, that's the boundary of how far away we can see. We can see the stars, which are much farther away. We can see the sun and the moon, which is much farther away. Light doesn't change really with distance. Um, it's not how it works. Although, you do get red shifting, which is, for astrophysics. That's only because of, you know, the space it occupies expands, which, uh, ex- like, what's the term I'm looking for? Like, smooths out the wavelength by a little bit because the space it's occupying is expanding, and over, you know, really large distances, that expansion smooths it out more, which makes it redder and redder. But still, you know, distance doesn't change the light. It's, you know, that's not, that doesn't have anything to do with the distance. It has to do with what the space is actually doing. Anyway, you know, if the earth was flat, you would, if there was nothing blocking your view, you would be able to see the whole damn earth. You'd look that way and see everything that, isn't blocked. And you look that way, you'd see everything. And, the horizon is there because the earth, you know, farther away from you, it, compared to the ground you're standing on, it curves down so that you can't see it, because to see it you'd have to look through the ground. That's literally what's happening. The horizon is literally where you can see the earth turn, like, curving away from you. You can literally see the earth curving away from you. And also, did you know that, you know, if you were to take, like, someone at your house, right? And you drive 10 miles away from your house, compared to the person who's, in your house, compared to them, you are 6 feet under the ground for every 10 miles away you are. Literally. And, and, up and down are only relative on the human scale of things, you know? Like, gravity doesn't pull you down, it pulls you in. And, I'd love to make a video about gravity and general relativity, because, oh my god, that, honestly, general relativity is what really got me into science. It's like what I started with, pretty much, and oh my god. Although the thing is with that, you'd have to, to really, like, explain it well, you need graphs and visual aids, and, you know, and I don't have the equipment to show that. I need like some kind of monitor system. I tried like making like a little stack and then like taping my phone onto something. It didn't work really. Um, I mean, I guess it could have if I really tried, but that'll have to wait. Um, anyway, um, and you know, it's funny that for most flat earthers, they're okay with everything else being a sphere, but not the earth. This one has to be flat. And it's like, I don't know, I think they're imagining like if you were to stand on those other objects, you know, your feet would be flat compared to the ground, which is not really how it works. Like they're really big, so the change in, you know, curving angle is very small compared, because it's just that big of a ball. Uh, and and like and almost all of them are based off, you know, the maps we make when, you know, our maps really are only are not actually really correct because we're taking a three-dimensional object and putting it on a two-dimensional side. So like those maps where it has Antarctica like spread across the whole bottom. Antarctica's not that big. I mean, it's pretty big, but it's not like that. You know, basically those maps, they take, you know, the top and bottom are the poles. So literally, like, you know, the whole bottom edge of the map is a single point, you know, and if you were to wrap it all around, it would make a sphere, right? So, like, the whole bottom edge is, you know, one point, and the whole top edge is one point that they spread out. And so, like, we can make sense of it. And also, Greenland is not gigantic. It just looks that way because, you know, the lines of longitude, or is it longitude or latitude? I think it's latitude. I could be wrong. Words, blah blah. But you know, going up toward the poles, they get narrower because it's going to a point. Um, and to make sense of it, they had to spread it out into a grid. So they just stretched out those points of those those lands to make it, you know, readable. But it's not actually like that. And yeah, maps are an interesting thing. It's interesting how hard they were to figure out. Um, and like if you see old maps, like none of them look the same because uh, you know, we're trying to make sense. We, you know, for the longest time we thought the Earth was flat because it looks fucking flat. It doesn't look like a sphere from any point of reference we can think of, and trying to map it out as a flat object just doesn't work, and it causes all sorts of problems that we don't understand with our feeble human minds. Um, and then and then you try to take like the sun and moon into account, which, you know, they can't have it. So where the, you know, so or some there's a bunch of different theories, but you know, the one I see most often is where they had the flat earth, right? And then they have the sun and moon like spinning above it, you know? And it's like, I mean, you can see in the sky that's not the case. I mean, the the sun goes from east to west. Um, Everything in the sky goes from east to west because we're spinning. Um, and you know, if it was spinning around in a circle above it, you would, in some parts of the world, you would see it going not only the opposite way, but you'd see it going from north to south or to south to west, or you'd like, it's not, no. Or some you'd also see it going southeast to northwest, or in all these different angles, and it's like nowhere on earth do you see that, um except like specific locations on the poles where you actually uh do see the sun circle around, because you know at that point there isn't more earth to cover it up, you know, because you're literally going around a little point and the sun's over there, and it's like you just, for like half the year because of tilting, uh you just, it's always day, so you just see the sun go around and around in the sky. It's kind of, I really want to see that one day. um that'd be cool. But what else? Oh yeah. Yeah, really, what's really got me to start this video was, uh, I was thinking about, like, you know, because all flat earthers, you know, they think down is just, you know, gravity, it always pulls down, and so down is just, you know, if you fall, you could fall off the earth and you would still go down away from the earth. And it's like, you know, not only what the hell is, you know, holding the earth up, but what really got me thinking was, what would happen if an asteroid hit on one of the sides? Like, you would have this thing where it would start to like swirl, like, you know, flop to one side and like spin, and like a spinning plate, and just rotating, and everyone would fall off, and uh and then one side would crash into the sun, and then and then the moon, and it's just like, what, like, holy shit. Like, and then, like, oh, how deep is this, you know, pancake earth? uh you know, like, what's holding it together? Where does gravity come from? Where, why is the sun and moon swirling around and not falling down? And like, what's making it swirl in a circle above the earth? You don't, they don't have any answers for this. They just, you know, it looks flat to me. So if I was walking on a round earth, fucking, we'd all slip down and slip off because of gravity. Or you'd have to, you know, like, no. Um, when I was in Boy Scouts, I remember I did this skit uh, around the campfire. It was like a parody off of like some flat earther I saw on the internet, um, where they were trying to explain why there's oceans. Uh, And they took an orange and they're like, this is round earth, and they poured water on it, and it's like all of it falls off, there would be no oceans. And then they take a plate and they pour water on that, and it's like, boom, oceans. It's like, yeah. Yeah. And then also you'd have to explain, like, how the fuck. This is just another thought I had. Doesn't really. It's not. I'm not really sure if I want to say that. Uh, like, yeah, no. It's crazy, how stubborn people can be, and honestly, really, it is, our fault that so much misinformation and so many people who don't understand how science works and are so, you know, against science. It really is our fault. In my eyes, every like problem that we have in the world, every like social issue, every, you know, uh, like individual, like problematic people, or and uh, all these anti-establishment cultures popping up, and the state of political instability that we have. It's all our fault because we didn't do a good job of spreading information and understanding of what science is and what we are trying to do. uh, and like science is, it's our collective ability, and in like to figure out things. It's how we explain how we get to every single conclusion that we have. And you know mm, we don't stick to something just because we thought it was true before. you know if the unless we only stick to something if we can find no conceivable way that it couldn't. We haven't been able to find a way that it can't be true. Not that it can't be true. Everything we know and uh, think we know, can in some way not be true, but we haven't found any actual evidence to support it not being true. You know, science loves when they find something that they didn't expect, or can't be explained by uh, their theories and laws, because that means we have something new to learn. And I guess I should be cutting these videos short because, unfortunately, in this new digital age, no one uh, wants to sit through an hour-long video, because we don't have that extended gratification anymore. Like, if you can't tell me all about it in 30 seconds, I don't want to hear it. It's like, what you don't understand is the more time it takes to build up to things, the bigger the reward is. We don't get that. Like, mm. I don't know what I'm talking about anymore. This video's getting derailed like all of them. Yeah. I think this is the only video about. I mean, no, it's not going to be true because there's going to be others that pop up that I can't ignore. But I'm gonna try to not do videos about debunking misinformation unless I think it's like really important or goes into interesting topics. Um, because it's just yeah. Just doesn't make me feel good. Doesn't make you feel good. And I don't know, it's kind of it can easily be viewed as an attack. And, just things like that really, with how the internet works, you just have to make it irrelevant to, you know, society and culture. You just, you know. Well, I guess this video is long enough. I don't know.